Okay, so again, 2D area review. You got about 5 minutes to answer those questions.
So you can do 10, 5, no, 5 times 3. Add that. Oh, 1/2 is heights and it's base plus base 1%. So basically the answer is going to be 22.
Yeah. Watch your head.
So it's 1/2. So basically just gonna be I remember cancellation. My diameter is 6, so oh wait, for number 3. No, I still a quarter of that, right? So you can just do 9, right? You can, if I get 6, I think I still. Oh yeah, because that's the 2. Yeah. That's me for 8 and 9. That way it's 6. The square and b squared equals Let's go, bro. Where would you like to go?
There.
Okay.
Thank you.
Yep. So what is the square root of 36? Oh no. X. Square root of 1. Yeah. That's why I have been thinking about it. I'm doing like 6 to 12 months to do like
I'm sure it's somewhere. Silence
Maybe 60.
One of the x over 2 squared, but the x wait, it's 8 squared. Wait, 7? Because it's no, we just flip.
So that means basically.
No, like is it on the 8 on the 7?
No, because that was just
Hypothetically. So it's an x wait, so it's minus x over 2 squared. So how do you calculate a square? That equals the height. That x squared divided by 2. So you do that times x over 2. 8. And then you multiply that by x.
That's my fun.
How you would find it? Is this right though? X over 2.
Well, no, it's 60 to do this. This ratio. So that's just
So the height I did x squared minus x over 2 squared, which is x squared.
wait.
So then I just made x squared over 4. That's your height.
So this is right I think so. Because that would be half the time, right?
Hey guys, you have like, I probably need people to start coming up and writing things up now.
Like if you're
No.
Oh,
You remember what I said? Should I just do manual? Let's go.
I go to
No, hey, no, don't do that. Hey, I forgot what I wrote. Are you seriously with the lost? You're not supposed to.
Yeah, or she was more than one.
I was kidding.
Oh, that's illegal. Take away someone else's participation rates.
Right. That's
What
why I
kind
said
of,
it's not
what
kidding.
kind of, what kind of things? Like,
Oh, I'm gonna find it. But I can't see what it is now.
I feel so appreciated.
Oh, wait, yeah, that's the same thing. Nobody did seven.
I did 7.
Then
I can go right on 7. Wait. I'm not sure it's right. I'm gonna go right in. Okay. Are you writing 7? You can write 7. Oh, he's not even in our class.
Hey guys, next Friday there will be a blood draw. You have to be 16 and older. Is anyone in there interested? Yes.
You killed the
Stick a little deal, right? No. They didn't usually harm me.
Well, I think so do you. Oh my gosh, this is the funny. I've spent more than 3 months in the UK from 19. That's me. Dang, I was in the UK from 1998, 1980,
All right. Let's take a look at these. Okay, guys, we're gonna take a look. Okay. 16, you agree?
Yeah.
Yes,
I agree.
You're good.
No, actually.
You guys agree?
Yeah.
You agree?
No.
You neither?
No.
Should be 45 over 2.
That's what I'm saying.
Base 1 plus base 2, 15 times the height, 45 over 2.
Wait, no, I meant 22.5.
Okay,
I was
You meant
Yes, no,
22.5?
because I was fighting with Igor.
Oh, I should
And
have.
Igor, you put 16.
Okay, I guess I should have realized that's what you meant.
Yeah.
Okay.
I just have sloppy handwriting.
That's fine. Yeah, you said sloppy handwriting.
Wait. You asked what he put for number 2 and 616.
That's okay. All right, number 3. Guys, listen. Semicircle with diameter 6, so that means the radius was 3. 3 squared is 9. 9 pi, but semicircle is half a circle, so that one's right. Okay, any questions on that one? Okay. Quarter circle, diameter 6, so 9 pi over 4 looks good. 6 for this one. Number 6, nope. So that would be,
16 seems to be the popular answer here.
it is 8 squared to 2 is closer. It's closer.
Oh.
It has to have a square root of 2 in it because you need a 45, 45, 90 triangle.
Exactly.
Okay? So hold on, let's do a review of that.
Oh my gosh,
So if this is x over root 2 and x over root 2.
Yes.
So our 45, 45, 90 special right triangle property. Remember you guys learned that one, and then you'd learn the 30, 60, 90, x over 2, root 3 over 2x. Right? Okay, so on this one, my base and my height have to be the ones that are making the right triangle. So, or the right angle. So it's 1/2 base times height. Or x squared over 4, which would have been the answer to this one. And so this one is, is it 16? Maybe it is.
Yeah.
Oh, it is, you're right.
Hey.
For the right reason or lucky guess? I'm not sure.
No,
Okay.
It is.
Okay.
I got
But the whole point is you had to remember that the square root of 2 for the special right triangles is in there. Okay, yeah, Chelsea.
We also just used like the Pythagorean theorem.
Yeah.
So that's fine, but I need, with what we're doing later today, the reason why I'm reviewing these 2D area things, we're gonna be building on 2D area and applying it to volume. You're gonna want a set formula for an isosceles right triangle, which is the purpose of the question, like me asking it this way. Does that make sense? Okay. This one might be equivalent. Let me see. 6, 8, 3, 2, 4, 2, 16 square root 3.
That's what I got.
But I don't think that, wait, It might be root 3 over 4.
That's what I got, 16 corrected.
Should be, I think it should be 2 root 3.
Oh,
16.
that sounds the same.
Well, but also, I thought the other one was wrong, so let's go through it, just in case. Okay.
It's 16.
So here, I have a x. I drop an altitude. So this is x over 2 and root 3 over 2x. Because this is my 30, 60, 90, right? So I'm just focusing on half the equilateral triangle. So in the end, I'll just double whatever my answer is, right? Is that all right? Question so far? Okay, so then I have 1/2 base times height. So 2, 4, root 3 over 4x squared is what, and let's see, x, so that ends up being the square root of x to the 4th over 4. Oh, you should have kept your over 2, that was closer. That's all right. Anyway, this is close. There should have been a 3 in there somewhere. This is the answer for number 9. No, yes. Oh, yeah. I don't know what my brain is doing. Because using this, 8 squared is 64 over 4, so that was right. Yeah. I don't know what my deal is. Okay, let me erase everything I wrote up because it's like all wrong. So where's my, maybe that'll help. So this is the formula for that using 30, 60, 90 triangle pattern, right? So 1/2 base times height, but then that's only the 30, 60, 90, so then I had to double it. So that's why those ended up canceling out. Does that make sense? I can't tell. Are you guys with me?
Yeah.
Yes.
Yeah? Okay.
Mostly.
I'm like,
You're like, what is that supposed to be?
hey, are we doing okay? Hey, I don't know if this is ultra lava worthy, but it's definitely write down worthy. Okay, with what we're doing later, all right? What was it? X squared over 4. Okay, I've got one more for you. Before we start the main part of our lesson today, I'm going to give you 1 minute is all I can do. That's enough time to write down that if you want and do my next question before we start our calculus portion of the lesson and move on from our geometry portion. I want a formula. I want a formula for the area of a semicircle in terms of diameter, not radius. Okay? I want a formula. Okay? I want a formula for the area of a semicircle in terms of diameter instead of radius. You guys have 30 seconds. Maybe a minute.
It's so sad. I forgot everything that I used to know
B squared times pi over 2. But then you have to multiply both of them, right?
Want a semicircle area formula in terms of diameter.
Oh, it's semi.
What if they're like, what's the area of a semicircle in terms of diameter? Just click right there.
Actually, yeah. I want to work. I think so. All I said was pi times
Spencer, did you just say you want to be a dentist and you don't think you're going to need any calculus in your education?
No, I want to be one of the elements. Oh, the semi.
So you think to go get a medical degree, you're not going to have to do any math?
That would be something for when I'm working.
What planet?
When I'm working, I'm not going to be like, oh, I need to like.
Yeah, but I don't think that's what the purpose of them making you do it is. They want you to be smart as a dentist in the medical
But what if
profession.
someone has a semicircle tooth and they're like, you only know the diameter and you're like, oh,
Sounds like a project for me.
I guess I'll just move business.
Alright.
Yeah, I'll practice Yeah, I'll just get fired. I'll get fired from my own.
Alright, anybody come up with something?
Yeah.
Okay.
the area of a semicircle in terms of diameter.
Okay. What do you got? Anybody? Yeah, Jose?
Diameter squared times pi over 8.
Okay, looks good to me. Okay. So, circle. I agree. So those are ones that if you're not great with like coming up with the Pythagorean theorem, like if you had a hard time with some of these ones, you may want to write those down. Like they're just good ones that are going to help make what we're going to do today easier. Okay.
Oh, okay. Yeah. Yes.
Yeah. You're telling me.
I know, and it's Friday, but then there's a 4-day week. I guess.
You. Okay. Monday's President's Day, I think.
Tuesday's a work day. I mean,
And Tuesday's a teacher work. Okay, so let's go ahead.
Yours is.
Okay,
I don't.
I don't care.
Wow.
I didn't ask for you. Okay, let's go ahead. Okay, guys. You guys, come on, let's get through it, okay? Focus. We're gonna deal with everyone's favorite function.
Oh yeah.
You already knew before I even said it, right? Is it a logarithm? Yes, of course.
My petition
I'm
is that
so
they
good.
should have started teaching us these ones.
Huh?
I always know the value of
I feel like they should have taught us logarithms.
Well, the problem is that to understand logarithms truly, you have to understand properties of exponents. And properties of exponents is something that, no, it's just something that is just always hard for people. If we end up with time sometime, I'll give you guys like a logarithm, like what are they day. I'm pretty good at explaining logarithms.
I
Maybe if we have time today. We'll see. At this rate, I'm not sure. But we'll see. Okay. Everybody have this written down there? Okay.
Yes.
So, last week, when we did volume, okay, we're going to deal with this region from 1 to 5 under the ln of x graph, like most of class today. Okay, that's what this one is here, right? Do you see it? Okay. What we did is we did volume based on a rotation. So I took some 2D surface and I rotated it, right? So like if I take this and I rotate it around the x-axis here, right? Then we found the volume of that. Now every volume that we did last week, the cross section, remember cross section is the new 2D shape, 2D space formed when I cut a 3D object, right? Every cross section of a volume by rotation is a circle. Why? Why is all the volumes that we've done so far based on circles? Okay? Yeah, Spencer's going like this. Carrie?
It would be rotating around something, and when you rotate around, it's going to be around.
Yeah, I mean, rotate around. Think of what's the definition of rotation, right? Rotate. Circular, right? That's the whole point. Now, and it didn't matter. Oh, this is a great. I'm too bad you're not in the video camera for that one. Yeah. Okay, so even when we rotated this region, right, around the y-axis, making a completely different shape, right? Come on, been prepping all day for this. All right, a completely different shape, right? It was still a rotation. So each cross section is still a circle, whether I rotate it around the y-axis, right, or around the x-axis, right? Because in the end, I was still rotating, so my cross section is still a circle, right? You guys with me? Now, a lot of things in life, I could find the volume of using a rotational volume, right? If I wanted to find the volume of my water bottle, right? It's got cross sections of circles, right? But not everything does. Is the cross sections of this circular? Is there any circle at all? No. Even like my remote, right? Maybe I'd use a cross section of some weird trapezoid looking shape, right? No matter where I chopped it, there's no circle anywhere in there. It's like some elongated trapezoid thing. Does that make sense? Okay. So that's what we're going to start working on today is how do I find the volume when the cross section is not a circle, okay? So the word rotation is a naughty word today. You have to put a ticket in my swear jar to say rotation, okay? We're not doing any rotation. We're not doing circles today, okay? So we're going to start with squares, okay? Squaration? Okay, I want you to imagine the orange coming towards you. Okay. Okay. You see, this is my ln of x region, right? Here is my ln of x region, right? So imagine the orange coming out at you. That's what I tried to show here with this fancy paper. Do you see it? No?
It's coming out. Well, yeah.
It's
See it.
kind of like the.
It's getting bigger.
Oh, like it's coming just forward.
Coming forward.
Oh,
Okay? Think of the vault thing that they jump on, the gymnastics jump on to go get on the palm horse or something. That object, right, it's like the one with the spring, but it's like a tighter spring. Does that make, you know what I'm talking about? That's an object that could be found using cross sections like this, where you have some rounded base, right? And then these squares are coming out at you. That's what's creating the volume, right? 2D area of my ln of x, but then the 3D is squares all along there, an infinite number of squares, okay, coming out of the whiteboard. Does that make sense?
yeah.
Okay? So, how do I find the area of a square? Length times width, base times height. Can I say side squared? It's a square, right? So the area of a square, side squared. Okay? What is going to determine, in this specific scenario, the side length of each square? What, in this specific scenario, is going to determine the side length of each square? The height, the y value, Nate? Dx. Okay, the dx is good. That's going to be how wide each square is. Okay, good. Okay, I heard y value. So, are you saying that each square, what's, hold on, I gotta do this on the camera. In my object here, what's this? That's the x-axis, right? What's this? That's ln of x. That's the function, right? So can you see that each square, okay, if I wanted to find the side length of the square when x is 2, how would I find it? So it's just 2? Plug 2 into the equation, right? Ln of 2 would be how tall the square is, the side length of the square. If I wanted the square at 1.1, I'd find the ln of 1.1. How big is the square at 1? 0. There is no square there, right? Because ln of 1 is 0. Okay? You guys with me? So if I wanted to find the side length of one square, I'd take ln of x, right? So if I wanted to find the area of one square, I'd do ln of x squared. We doing okay, Spencer?
Does that mean that there's an infinite number of squares that can be in
Yes, then there has to
it?
be.
So it's not 7.
Yeah. So this right here, ln of x squared, is just going to represent the area of one single one of these squares, if I knew the x value, right? So Spencer says, does that mean there's going to be an infinite number of squares? Yeah. And none of them are going to have the same size, right? Because none of these have the same x value as I go along. You with me? Okay, so how do I mathematically, what function that we've been working with allows me to take all the infinite amount of something over a certain domain? That's what the integral does. So this represents side squared for one square, right? So if I want all of the squares from 1 to 5, then I take my integral. So now that's representing all the infinite squares infinitely close together with a dx at 0, right? Or approaching 0, and adding them together. Okay, how are we doing? Doing okay? Okay, so now we're going to do another one. This time, okay, so let me write down what this represents. I don't really care about the decimals yet. This is what is more important for this. So this is the volume of a solid with square cross sections. The vocab word solid means 3D object. Solid 3D object, okay? Okay, so now let's do one, but this time I want to do okay, so I have my ln of x from 1 to 5 again. This time I want the volume of solid with semicircle cross sections. Now, hold on. Ln of x represented the side length of the square, right? What does ln of x represent if my cross section is a semicircle? The diameter. Okay? If the semicircle has to, do you guys see that everything I glued on is the ln of x region, right? Does that make sense? Okay? So, and if it helps, like, even if you bird's eye viewed, right? That's what is determining where the mushrooms grow. I know that sounds weird, but for me, like, this type of volume, instead of thinking about I'm allowed to say curse words because I'm the teacher. So instead of thinking about it rotationally, I know, right? Okay. I like to think of it like you have a base region as your ground, and these mushroom shapes are growing up out of it. Because there's no moving around anything. It's just that this shape, right, is growing up out of whatever my base region is. Does that make sense? That's kind of how I talk about it. But if my semicircle is what's supposed to span that entire base region, then it has to be the diameter. Do you see that? Do we know how to find the area of a semicircle in terms of diameter?
Yes, we do. Oh.
What? Okay. So if I was going to do that, then I could come here and take the area of one semicircle, right? So there's my semicircles coming out. The area of one semicircle is going to be pi over 8 ln of x squared, right? That's going to be the area of any one semicircle given if I knew the x value. But I don't want any one, I want all infinitely many of them, right? So that's where the integral comes in. Guys doing okay? Okay, we're gonna do another one. You ready? This time I want volume of solid with rectangle cross sections twice as tall as wide. When they say as wide, wide is always what's on the base region, okay? How do I find the area of a rectangle?
Width times height, or base times height.
Base times height, right? Now, is there a way for me, so you can see the base region, right? Now, is there a way for me to find that height in terms, okay, so which one is ln of x, the base or the height for the area of that rectangle? Which one is ln of x?
The height, yeah.
The base. The base is always what's on my base region.
Oh, okay.
Okay? Does that make sense?
Yeah.
Okay, so if I have this here, is there a way for me to rewrite this only in terms of the base? Based on the information that they gave me. Caleb says yes. What did you, how? Sure.
You just do ln of x times 2 ln of x.
Good. The whole point is that I know, right, the base, like Caleb was saying, represents ln of x, right? So if the height is supposed to be twice as tall, even though the height is not touching ln of x at all, if I know it's twice as tall as wide, then don't I know that each of these are 2 ln of x tall? Does that make sense? Good. So like what Caleb said, I'd have ln of x base times the height. 2 ln of x. How many rectangles does that represent? 1. But I want all of them infinitely many from 1 to 5. How are we doing? Okay? So far okay?
Yes.
Okay, I'm going to give you one to try, and then we're going to try and put it together before I make it a little trickier. Ready? This time I want the integral expression and the number to 3 decimals, okay? So this time, same region. I want the volume of a solid with quarter circle cross sections. Same one, yeah. Or else my visual won't work.
Right here.
Okay, it's okay if you're not done, just as like a checkpoint. Okay, so the ln of x represented the side on the square, the diameter on the semicircle, the width on the rectangle. What does it represent if the quarter circle is what's supposed to span the base region? The radius. Can you see it? Right? If a quarter circle is what's supposed to go the whole way, right? Does that make sense? You guys see it?
Confused, like,
Oh, so
visualizing it.
yeah.
Like, I never
It's
knew
not the
which way it faced. So it's like, and if you're looking from a front view, that's where.
So the ln of x region is always like, if I was going to bird's eye view any of these, I wouldn't even be able to tell what shape it is, right? All I can visualize is bird's eye view. All of these are just the same as ln of x from 1 to 5, right? So like, I can't tell what's going on any of them, right? So it's when you turn it to the side,
It's that shape.
that's the shape. So the idea is that anywhere I cut this object, right, and open it up, this is the shape that's going to be formed. Think of it like on this one, where if I'm looking at it like this, do you see how you're still visualizing only, that's the wrong way. Okay, like this, right? You can't tell. It's not till you look at the side that you can see the rotation creating the circle.
Yeah, and then does it matter, like, with the quarter circle, does it matter, like, if it's facing that way, or does that make sense?
It does.
How do you know?
Okay, so for everything we are going to do today, every cross section is perpendicular to the x-axis. So they're always going to be like some dimension in the 2D shape, in the 2D cross section, has to be formed by ln of x. It has to be formed by our y equation. And then they're kind of growing out from that.
Yeah.
Does that make sense? Okay, good. Anyone else? Okay, so on the quarter circle, it would be the radius, right? That's trapped by the ln of x. Does that make sense? Okay. So then I go the integral from 1 to 5 dx, that's going to be all my quarter circles added together. And it would be pi over 4 ln of x squared. Pi r squared over 4, same thing, right? Does that make sense? Anybody get the decimal? How are we doing? Okay? Okay. Here's kind of the summary of what we're doing, right? The idea is that all of these have the same integrand, right? Because they all have the same domain. Good? All of these have the same function, ln of x, plugged in. Because the ln of x is the same, right? And then, hopefully, the better you get at these, what you're going to start being able to visualize is that inside my integrand is the area formula for the 2D shape. Does that make sense? You guys doing okay?
Yes.
What questions do you have before I have you try a couple more on your own? Anything? Okay. I'm going to have you guys try some and let's see how we do here. Can you take 5-6 minutes? Try those with your neighbors. And then we'll go over them, and then we'll go through the last piece of this puzzle for today. Excuse me.
Is it still from 1 to 5?
I'm not telling you. I gave you enough info to figure out the domains.
Oh wait. It's from 1. So, in Ellen's case, it would yeah, I'm pretty sure. This is from where I oh wait, that's just
Oh,
that's just great.
I think it's the same.
so that's what we, like, that's one of the sides.
Just we're just going to that one.
Let's see, at 5.
Can you pretend that all three of these sides are the same? So, this is the region.
That's like my trouble. I think I can't like visualize it very well.
It's hard to visualize, that's why I gave you.
Like kind of coming at you. This is very helpful.
Yeah, the point is coming at you.
So it's not like the bottom.
This is the x-axis, this is the element of x. And the point is coming at you.
Is the shape always gonna be on the
Is the shape always gonna what?
on the z planes? Like if this is x.
You can call it a z-plane, be careful because the z-plane would be more like if these are all like,
I don't know.
the same distance out, but if it helps you visualize it, absolutely visualize it that way, because the shape is what's coming at you. That's what's making it 3D. If it wasn't on a Z-ish type thing, then it would still be a 2D area. So think of it like when we have our rotations, when they rotate, they're coming off the whiteboard and creating 3D. That's what's happening here, these shapes are just growing out to create 3D.
That's why I was like flat, flat. That helped me like.
That's good.
Do this. You always keep your area, right? So
Yes.
Yeah,
If it's a leg, it's gonna be basically 10 divided by 2. So it's gonna be this for this thing right here. That's base and tight. And then divided by 2. With this other one, we're saying that this is x. So we're finding these two sides will be x. This one, we find negative x.
Now, I also just, while you're working, I just want to say if you guys, like, don't end up getting those 3 newish formulas I put up there memorized, you can still figure the problems out. Like on this one, if you would have just taken your normal diameter over 2, squared all over 2, right? It's just these ones are nicer, so they're a little bit easier when you're typing it in your calculator to hopefully make sure you don't mess up your parentheses and things like that. Does that make sense? That's really the only reason to write them out like that. It just makes it easier to type into your calculator. It also makes it a little easier when we start integrating by hand, because if I had asked you to do this one by hand, you could have pulled the pi over 8 out of the integral, and then we would have done a power rule with this one. And that's a little easier to see than when I have r over 2 squared all over 2, right? So that's the purpose of that. But if you don't have those memorized, I don't want you to feel like you can't do the problems. Okay, you just have to visualize your normal old school geometry formulas using Pythagorean theorem or whatever.
I don't know how to first of all, like, this is an exponential equation now. It has a value. Wait, so what do you
What? We need the x. Well, because you have x as a value.
Yeah.
Oh, it doesn't, but it shouldn't mess with the numbers because when x has a value, your calculator knows
So, on this
when you
first
type
one,
it
it's
in
a leg,
here
right? So
to
it's
leave
gonna
a
be
variable x.
S, here's our y. This times height, which is y squared divided by 2.
Does that make sense?
We don't know.
So
what
your
the
calculator will know, like,
like,
if you had, like, you know, like when you do derivatives at a point and you plug the x in and you can remember like x equals x or whatever, your calculator knows like that one it wants the number, but it knows
Like
that
so
this
good,
one
because it's like.
Oh, I thought we found it because we
It's
know.
Yeah, I wasn't sure.
That's okay, here's how I know. If it thought this x was a number, then this would just be representing a constant value. And it would have the same. Would it be from 0 to 5? Yeah. No, it's not here.
Okay, because it kept doing like a weird number, like I wasn't even
We don't know, actually.
No, your calculator, it doesn't have a break. Once in a while, it has a little bit of a break. So it knows that in this situation, like the way this integral function is programmed, to leave these x's as the variable, not as 3.303. I promise.
2196 minutes.
So I can sit down for a second.
What? Remember, no,
Yeah, thanks.
I got 2.103.
That's excellent.
No, I was really just hoping that it's
So it's the.
And then if you put it in your graph,
Oh,
yeah, I did the same thing, because I thought it said y. So I was like, okay, range is 0.
Can't assume 0. It wasn't the y-axis. That's what I said. It only has 2 fences, so we should be going from 9 to 2. So the boundary lines given are the only 2 ones that are allowed to be creating a fence.
What did you get for what did you get like 17.9? Yeah, for the, sorry, for the first
Oh,
A. So for number 1, what is that?
You guys doing okay? Here, let me- So these triangles aren't isosceles, but can you pretend they are? Well, this one actually is isosceles. This would be hypotenuse oriented on the region. So the right angle is what's in the air. Okay?
Oh, so the region is the hypotenuse, and then the other.
In this one, you'd have to imagine if this were isosceles, this one would be much taller, right? But the right angle is what's here. Does that help?
So this one.
This is the hypotenuse on the region, this one is leg on the region.
Oh, well that makes sense.
So it's where the right angle is, which determines what I call base and height when I do my area. Yep, does that help?
Yeah, I think the hardest part is just finding out.
Anyone, am I going too fast? Are we ready to start putting some things up? Anyone want to come up and put number 1? Anyone want to come up and put number 1? Josie, that's fine. There's like 6 people gone today, so, and I've had a lot of volunteers today. What about 2A? Anybody willing to come up and put 2A? And then 2B?
Is the x,
Anybody willing to come up and put 2B?
does the x represent the hypotenuse?
Caleb, you don't have to write it right under, just write it next to it or something. Thank you.
So you did 2B sit?
Okay guys, let's take a look. And then we've got one more piece of our puzzle to add, and then we're done. Yay! Okay, hold on. Here, 1 to 5, right? Root 3 over 4, side squared, right? Looks good. Now again, if you didn't have the equilateral formula memorized, you could try doing your Pythagorean theorem thing that some of you guys did at the beginning. I'm just trying to give you a simpler way since this is already a tough concept like related rates anyway, right? Okay. Any questions on that first one?
No.
Okay, let's look at the second two. One big mistake people made on these second two is they would assume that it would go from 0 to 2, but that would only be if it told me the y-axis was also a boundary line, right? Okay. Now, there is one issue though, because these are different questions and I have the exact same answer. Okay, so I want you to think about it, like visualize it. Which one should be bigger? Okay? Which one should be bigger? If I have a leg set by a region or the hypotenuse? The leg should be bigger, right? Because that means the hypotenuse is bigger than the region if the leg is here, right? Okay, is we doing okay? This one is, I know is right because it follows our area formula here, the one I had you do before, where the hypotenuse was on the region. Does that make sense? Okay, so what I want to do is help you visualize this one. If I had here, like this, if the leg is on the region, that means that the right angle is like here. You see it? Yes or no? Do you see it?
Okay, I can.
So that means this equation represents the base of the right triangle, right? And the height, because I said they're isosceles. So 1/2 base times height, or 1/2 base squared. So this one just should be a 2. Does that make sense? And that matches with what you guys said, where the one with the leg on the region should have been the bigger one, right? So our denominator was smaller. Okay. These aren't exactly, I mean, this one is hopefully helpful. Like you can see that when the hypotenuse is on the region, right? The right angle's up here. This is my hypotenuse length. This one, you have to imagine that this length and this length, imagine this triangle bigger, so it's isosceles because it's not right now, right? But that's what it would look like if the leg was on the region. Okay, you guys are doing okay? All right, let's stop here. What questions do you have before we do the last piece of this for today? Anything? Okay, last thing we're gonna build on this today. I'm gonna see if you guys can figure it out first, based on what we're talking about. I don't care what the cross sections are. Okay, you want to? You'll take it back. Okay, so what's different about this one than the other ones we did today? What am I adding to this? It's not just one equation, right? It's the area between two equations is our base region. So basically we're combining like all the volume and area stuff we've been doing. And I want you to see if you can figure it out before I walk you through it, okay?
Wouldn't it just be in this? Okay.
Is that where you use, wait, is that where you use?
Sign
Yeah, that's what I was thinking. The thing that you actually plug in is just Saturday night. Did you guys figure out the intersection?
Oh, yeah, in that specific.
Erasing it all? Yeah, the next test will be on here. Write the integrand and get the decimal just to, because that's the easiest way to check.
Oh, I did square.
So it would be sine minus cosine.
There you go.
Oh, that's all.
So it's like
Whoops.
this part, that line. Yeah, so it would be just like the LN, the LN one. Coming out like that, the round and part is a like the diameter. That's flat, like
But now I'm working on it.
okay, so then the circle part.
Did I not push it? Can you put the height?
It's like this is this is the diameter.
Oh, wait, no,
On the
yeah,
out,
my bad, my bad.
Wait, just sign it.
My bad.
I don't know, I just feel like it's easier to visualize.
I definitely did this one. I started to realize because at first all I did was well, no, you can like intersection points. Because I got 0.75 Oh, duh. Okay, yeah. Okay, yeah, it's the same. Okay, it is. I was thinking
Can anybody come write it up? Anyone wanna go write it up?
Oh, okay. Because at first I did seconds. I was
Oh, wait,
I did sine, and then I did minus another pi. And I guess, but still.
No, I don't.
Hey, you got those guys. Let's go.
To get height.
It's like a light up here, like. It's seeing like a flash. It's not helping my migraine. It's driving me crazy.
Oh, really? I got like 83 out of my 5
I was not.
So you gotta put it outside of, well, outside of these parentheses. Yeah, kind of squaring, like, there you go, yeah.
plus and curves that.
Well, I was wrong. Oh, wait, did that. Actually, I don't know.
Oh, no, this is put in as.
I just did that on
Actually, no, I think it's more like an educated guess.
I guess.
Actually, actually did some.
Wait, you had like pi over 5 or pi over 1? Okay. Nah, you're good. I assumed it was an 8. I was just like,
It was Sorry, I'm very nice.
You actually did it right. Let's go.
Yeah, because we were like,
No.
Oh, yeah.
I know, but then you don't have a week for test corrections.
And it's like third.
And you only have one person in grade, and that's really
Oh my gosh, I don't like the position that leads is nuts. No, don't put a calculus test that's
We have those there. I just,
second or
those ones are all in term 4, and I want.
Do seniors have to go to the
Okay.
Do seniors have to go to the
Okay, guys, hold on. Guys and girls, quiet, please. Let's go through it. This is kind of the culmination of everything we did today, right? So, the sign, I just want to make sure they can see, yeah, they can see that. Okay, these here, pi 4s, 5 by 4s, that's where these intersect, right? Okay, I know that if I know my unit circle, I know that's where they're the same. You can calculate and find where they intersect on your graph mode too, then you have decimals here. You'll get the same answer as long as you don't do any intermediate rounding, right? And here's our semicircle formula, pi over 8 diameter squared, right? Now the diameter is the base region. Before, we just did a y-coordinate, right? When we just had one function. But this time we got to think about it. It's the distance between these two functions, or the area of that black shaded region there, right? Well, when we've been doing area, don't we always do top minus bottom equation? So that's why that's plugged in where the ln of x went in the other part of class. This looks right, okay? What questions do you guys have? Anything?
But you know how you said there was a light flashing?
Yeah, is it?
That light is flickering.
Okay, I'm glad. I was like, is it my migraine is so bad? I'm starting to see flashing lights. Okay, you guys, homework. Listen, please. Homework tonight. Okay, don't hate me if you do. It's for your own good. But there will be 2 assignments. There'll be a normal bookwork one covering cross-section volume, and then I am going to do an AP Central review assignment to get you through the 5 days. Okay, I would prefer you not do them both tonight or tomorrow. I would prefer you save the review one for Monday or Tuesday. That way it actually serves the purpose I'm intending it to serve. Okay? I'm going to text them out. Thank you.